Well, thank you all for coming. Today's session, VMware Cloud on AWS. We're going to give you a little bit of a storage deep dive. Tell you a little bit about what we're doing from a storage perspective within this new service that we announced, VMware Cloud on AWS today. But before I do that, let me flash this up on the screen quickly. This is our disclaimer. We will, towards the end of the session, maybe touch on a few areas that we're working on in the future. So please feel free to read this. As we talk about any future-facing items, just please be aware that there's no commitment to deliver in any specific time frame or specific versions. So, we're just giving you a little bit of a taste of what we're looking at, what our thoughts are in our future directions. So I hope you've all had a chance to read and absorb that. Just to quickly introduce myself, my name's Ben Meadowcroft. I'm a product line manager at VMware. I've been at VMware for about 5 years in our storage and availability business unit. And one of the things I've been working on for the last year or so is really looking at how we can bring the product and feature set from the storage and availability portfolio of VMware into VMware Cloud on AWS. My colleague Matt, I'll allow him to introduce himself.
Hi, I'm Matt Emder. I'm an engineer working in the storage and availability business unit, and my focus for the last year has been on how to bring vSAN from on-premise into the public cloud.
All right, thanks, Matt. So Matt's really been instrumental as one of our leading engineers in this effort. So let's talk a little bit of context first, and then we'll get into I promise, after the marketing slides, we'll get into the tech deep dive. So let's just bear with me as I give a quick overview of VMware Cloud on AWS. Then I'm going to hand over to Matt, and he's going to talk a little bit more about the host configuration, the cluster configuration, what it's actually going to look like practically on VMware Cloud on AWS. Then I'll cover a little bit, then Matt will cover a little bit on the operational model for vSAN, how things are different compared to how you would be used to managing things in your on-premises locations, compared to how you would manage things in VMware Cloud on AWS. And then at the end, I'll talk a little bit about some of the areas that we're looking at pushing on further and developing further as part of our portfolio in the storage and availability space. So first, the overview of VMware Cloud on AWS. Really, VMware Cloud on AWS comes out of an evolution of our thinking in our cloud strategy here. I'm sure you're familiar with what we've been looking at in terms of enabling any device, any application onto any cloud. And VMware Cloud on AWS has a very specific role in that. It's really about extending the capabilities that our customers are familiar with, the value that they see from the SDDC stack from vSphere, vSAN, NSX, and allowing them to bring that to the public clouds. And not just any public cloud, but the #1 public cloud, AWS. And so, we're really grateful that we've been able to work very closely with AWS in bringing this to market. So that's really what VMware Cloud on AWS is about. It's enabling that consistent operational experience, bringing it from your on-premises and then enabling you to extend it into the cloud. And there's a few key areas that we're covering with this. The first one is that that rich full SDDC stack. So it's not just plain vSphere. You also get all the power and capabilities of vSAN, all the flexibility of the policy-driven management that you have with vSAN, and its resiliency and performance, and able to bring that to the cloud. The consistency and familiarity of VMware technologies. So I'll touch a little bit later on about how we're working with our ecosystem to bring not just our own technologies, but also a broad ecosystem of technologies along with us on this journey. And then how we're able to really provide hybrid capabilities, workload portability between both on-premises and the cloud. Direct access also to the power of native AWS services. That's one of the things that really differentiates this, is that you are able, once you're in VMware Cloud on AWS, to be able to reach out into that rich set of services available on AWS. And then also being able to take both your existing applications and other newer applications that you're running on the VMware platform and bringing those into this environment as well. But really the key thing is that we're taking those proven, trusted technologies that you're all familiar with and enabling you to consume them in a new way on VMware Cloud on AWS. So this is a very quick overview here. I kind of mentioned these key technologies. We have vSphere, vSAN, NSX, vCenter. These are tools that many of you are already familiar with, providing your compute, storage, and networking capabilities, giving you that agility in your on-premises environment. And so this is what we're bringing, something that we operate for you. And so we're responsible for the lifecycle management, and we'll talk more on specifically how that works with and the delineation of responsibilities on the storage side a little later. But supporting, you bringing your VM workloads into this environment, but also coupling it with the ability to have on-demand capacity consumption as well. So you can very quickly expand and contract your capacity as desired. And then as well as delivering that stack, then extending it back to your on-premises, enabling you to have the power of that connectivity between your on-premises environment in your own data center into the cloud. So a lot of capabilities. We'll touch on a little bit what we're looking at here from disaster recovery, and we have a tech preview session of that later today. But also some of the hybrid capabilities that we'll enable with VMware Cloud on AWS will allow you to move those workloads very easily back and forth between the two sites. And then, as I mentioned earlier, the ability to then reach out and be able to leverage some of those other capabilities that you can get from AWS as well within your VMware Cloud on AWS environment. So hopefully that's given you a little bit of an overview of what VMware Cloud on AWS is. Just to try and get everyone on the same page there. It's essentially the SDDC stack delivered and managed by VMware on your behalf that you can consume in a very flexible way on top of the public cloud. So I'll hand over to Matt and let him talk a little bit more now about the vSAN configuration and the cluster configuration. Matt, thank you.
Thanks, Ben. Thanks, everyone, for attending. So before we jump into the details, I think looking back when we sort of started this effort, we said we want to bring vSphere to AWS's public cloud infrastructure. And as I'm sure you are all aware, vSphere has a strong dependency on shared storage. It underpins a bunch of our key functionality for HA, DRS, vMotion, all of the features that our customers really tell us are important to them. And when you look at public cloud infrastructure, there's a lot of scalable storage services, but they don't necessarily meet the bill for what vSphere needs. So things like EBS have a lot of great properties, but aren't quite compatible with ESX. And meanwhile, on-premise, you're all familiar with vSAN, I'm sure you wouldn't be sitting here. So vSAN was built and bundled with vSphere as an HCI solution. And we've seen HCI really start to transform the modern data center because it provides a more powerful and easier way to manage your physical infrastructure. And it allows you to streamline and operationalize your storage management. And so we sort of said, okay, we have this technology that was built and designed for on-premise. How do we take that and use it as a platform to build a scalable storage system on top of public cloud infrastructure? And so to start, we need infrastructure in the public cloud that's compatible with ESX and vSAN. And if you're familiar with Amazon's EC2 offerings today, all of those EC2 instances are they themselves virtual machines. And for VMC on AWS, we didn't want to rely on nested virtualization. So we worked very closely with Amazon, and Amazon actually built us a new instance type that's based on the hardware for the i3 16 extra large instance, if you're familiar with it. And that allows us to run ESX on top of bare metal in AWS. And so this new bare metal instance type becomes the building block for what vSAN is going to use. The machines that Amazon has put together for us are somewhat beefy. They have about 36 cores per host, half terabyte of memory, and 8 1.7 terabyte locally attached NVMe SSDs. And if you look at this should look pretty similar to what you see for a vSAN ready node on-premise today. And there are a few things that I think are worth calling out that are a little different. The first is that all of the NVMe devices are the same. We don't have different tiers of devices for the caching tier and capacity tier. And while we've seen on-premise customers adopting NVMe, especially in the caching tier, the capacity tier in VMC is much more performant than what we see in a typical on-premise deployment. The second thing to call out is that AWS has added some secret sauce that allows us to boot ESX from an EBS volume. And this has a lot of benefits because it gives us some storage where we can have logs, traces, core dumps, without having to sacrifice any of the locally attached devices. So all the locally attached NVMe devices we can dedicate to vSAN, and we still have storage for all the things we need to do to manage ESX. And the last thing to call out is that the NVMe devices here are actually using encryption at the device level with keys managed by AWS. And so this ensures that all of your data at rest is encrypted, and that as instances are terminated and returned to Amazon, if there was any data on those devices, no one can read it. So from a vSAN standpoint, we're basically taking this host, this is our building block, and AWS only has a single hardware configuration. So the i3P is our blueprint and the building block, and all vSAN clusters will look the same in terms of every node is identical. We take the devices and we split them up into 2 disk groups. So each disk group has a single caching device and 3 capacity devices. And similar to on-premise, we're doing this to take advantage of parallelism that we can get between disk groups and to limit the blast radius when there's a failure. So if a device fails, we have 2 disk groups instead of 1, limits the amount of data that we need to move. So now that we've gone over sort of the host configuration, I want to talk about what an STDC and a vSAN cluster on AWS actually looks like. And as Ben mentioned previously, this is a managed service, so it's a little bit different. In VMC, as a customer, you don't have to worry about provisioning ESX, installing ESX, configuring VC, configuring vSAN. That's all done for you. It's managed by the service. It's part of the managed service offering. So when you come to the VMware portal, all you really need to tell us is how many nodes you'd like to provision. And the initial availability is between 4 and 16 nodes. And give us a little bit of information from a networking standpoint so we can make sure we lay out the management IP address range in a non-conflicting way. At that point, the service comes along, talks to Amazon to provision the instances that you need, installs ESX, installs VC, installs NSX, configures everything, and configures vSAN for you. So the end result is that you get an STDC stood up. From a vSAN standpoint, the cluster configuration is relatively straightforward. AWS doesn't support multicast, so vSAN is using unicast, which we support on-prem as well. All of the nodes are in a single availability zone, so there's no need for stretch clustering. And in the initial release, dedupe, compression, and encryption are all disabled. From a customer standpoint, what you're really getting when you provision an STDC is a single VC, and that VC has a single cluster. All of the nodes in the cluster are part of the vSAN cluster. And what looks a little different here than on-premise is that vSAN is really the only storage that we have. And so we're putting virtual machines that we need to manage the infrastructure, like VC and NSX, on top of the same vSAN cluster where customers are going to be running their workloads. And that leads to some interesting challenges from a permissions management standpoint. We want to ensure that, so there's a number of permissions in these that are allocated in VC at the granularity of a data store. You can think of these permissions as things like file management, which allows you to go to a data store and create, delete, and read files. And this is really important for a number of use cases, but especially for things like backup. Now, we want to make sure that we deliver on that promise of giving you, the customer, the same operational experience you have on-prem in the cloud. So we don't want to restrict the permissions we give you on a data store. On the flip side, we want to make sure that you can't accidentally or maliciously do anything that would impact the infrastructure VMs that we're managing on your behalf to control the cluster. And so what we've done in VMC to solve this problem is build some new functionality into vSAN. So vSAN can expose multiple data stores. vSAN will now expose one data store that's owned and managed by VMware, where you, the customer, don't have any permissions. And that's where we put all of the infrastructure VMs. There's a second data store that's for the customer that you manage, that you have full permissions to, and you can do whatever you need. This allows us to give you full permissions to manage the data store just like you would on-premise, without introducing any risk to the service. And from a vSAN standpoint, it's worth calling out, these aren't really full-fledged data stores. They're still a single vSAN cluster. So any cluster-level configuration, if we were to eventually say enable dedupe, is going to apply to both data stores evenly. You can really think of these as namespaces. There's a single pool of capacity. It's just being exposed in two separate namespaces. Underneath the covers, what vSAN is doing is really keeping a mapping to understand which namespace a given VM should be presented in.
I think one thing I'll add to that, Matt, just very quickly, is just to make sure everyone's clear. This is a new capability that's introduced into vSAN, but it is specifically for VMware Cloud on AWS only. This is not a general purpose capability that you'll see in your vSAN releases on premises.
That's a great point.
Thank you.
So I've talked about the host and cluster configuration from a vSAN standpoint. I want to touch very quickly on the networking aspects as they relate to vSAN. What I'll say first is that networking in VMC on AWS is relatively complicated, and there's going to be enough content to cover many other breakout sessions. I'm not going to be able to cover it all here. But the key things to understand, I think, from the vSAN standpoint is that there's really two separate networks. There's a management network that's controlled by VMware, and there's a customer network, which is where all of the customer VMs. And the management network can be bridged to on-premise, so we can give you that hybridity that you want. But in VMC, customers don't have permissions to attach their VMs to the management network. From a vSAN standpoint, what this means is that we've carved out a private network for vSAN on top of the management network. And from a routability standpoint, it means vSAN traffic can only route to ESX nodes that are in the cluster. So you can't bridge the vSAN network to on-premise. And this follows the best practices that we have for vSAN on-prem today, where we basically tell you you should have an isolated network for vSAN traffic so it doesn't commingle with any of your other data center traffic. So we've gone over some of the details in terms of what the cluster configuration looks like. And now I want to change gears a little bit. I think Ben mentioned this, where as part of a managed service, we're using vSAN, and it's the same product that you have on premise, but the operational responsibilities in VMC on AWS are a little bit different. With a managed service, there's a new division of labor. And at a high level, you can really think of this as anything having to do with physical infrastructure or the software lifecycle of vSphere and vSAN becomes a VMware responsibility. Anything related to provisioning virtual machines or running your workloads is a customer responsibility. And we'll walk through a few of the key examples and how things look different on VMC and AWS. So being a managed service, VMware is now really taking on the responsibility of how to deploy, configure, patch, and upgrade. And what we've heard from customers is that part of the value that they see from moving to the public cloud means that they don't have to worry about infrastructure management. These are all taxes people pay on-premise today because they're managing their own physical infrastructure. They don't want to do it. They have to do it because they need it to run their workloads. So in VMC on AWS, instead of being a customer problem, this becomes a VMware problem. And one of the more complicated workflows to go through is how the service handles patch and upgrade. And the feedback we've heard very clearly from customers is that managing the vSphere and vSAN software lifecycle on-premise really isn't as simple as painless as it should be. And while we're continuing to invest in improving that experience on-premise, in the cloud, we're really trying to remove that burden altogether. So when the service is going to orchestrate a patch and upgrade process, it's broken down into two phases. There's the control plane, which consists of things like VC and NSX. And there's the data plane, which consists of all of the ESX hosts. The time to patch and upgrade the control plane is fixed. The time to patch and upgrade the data plane is going to depend on the number of nodes that you have in your cluster. From a customer standpoint, when we're doing the control plane upgrade, VC is unavailable. But you, the customer, get to tell the service the windows in which you want it to orchestrate those types of upgrades. From a vSAN standpoint, things look slightly different than they do on-premise. In AWS, we have the benefit of having an infinite pool of capacity. And so when we start the data plane upgrade in AWS, we have the ability to dynamically provision a new node and add it to the cluster. And you can't really do that on-prem unless you have extra hardware lying around. This is the value of the elasticity that you get in a public cloud. So when we start the upgrade process, the first thing the service is going to do is provision a new node and add it to your cluster. And that's going to ensure that while we're doing a rolling upgrade of your hosts, you have the CPU, memory, and capacity that you've paid for. Once that new host has been added, we'll pick the first host in the cluster, and we'll put it into maintenance mode with with ensure data accessibility. And so the service typically isn't going to start an upgrade of a host if there are any components resyncing. So this operation should be relatively fast. We don't really expect much data movement when this starts. Once the host has been put into maintenance mode, the service is going to put down the new bits and reboot it. It's going to wait for it to come back up, rejoin the cluster, and resync its components. Once the host is back in the cluster and all of its components have rebuilt, the service is going to go pick the next host in the cluster and start the rolling upgrade there. Once we've patched all of the hosts, effectively we take that extra host that we added for you and we pull it out of the cluster, and the operation is complete. And from a customer standpoint, aside from telling us when you want these operations to be done, that's all. There's no responsibility. Everything is handled by VMware. And so while we're taking on responsibility for vSphere software lifecycle management and vSAN management, we understand that policy-based management is something that's really critical. As you guys know what your workloads are much better than we do. So we didn't want to restrict customers from being able to create their own storage policies. This means that in VMC on AWS, just like on-premise, you have the ability to set whatever policy you want for things like host failures to tolerate, whether or not you want to use mirroring or erasure encoding, whether or not you want capacity reservations, for whatever workloads you need. And in VMC on AWS, we have a new H5 client, and we have a quick demo where we can walk through what this actually looks like. So before I start, quick show of hands. Have folks here seen the VMware H5 client yet? All right, so a couple of folks. Excuse me. So for folks who haven't seen it, this is the H5 client. It should look pretty familiar to you. It's sort of designed to look like the existing client. For storage policies, pardon me. For storage policies, we can navigate just like we would in the existing client to the menu and storage profiles. And here we have the ability to create and define our own storage policies. In this case, we're going to go ahead and create 3 storage policies. The first is going to be a generic policy for the OS disk of the application. And so here, I can choose, maybe erasure encoding because I don't really care about IOPS or performance for this. And then I can create an additional storage policy, which in this case is for a SQL application. This is where I'm going to store my data files. And so again, I give it a name, and then I can configure this policy. So as an example, again, maybe we'll do RAID 5. And then lastly, I'm going to create a third storage policy, and this is going to be for the device that I want to use for the logs for my database. And here it's that flexibility to say, for the logs in my database, I may want to use RAID 1 mirroring, so I have less I/O amplification because I know that the workload on that device is going to be higher than the rest. And by giving you the ability to create your own storage profiles, we don't limit you. You can configure this however you see fit. Once I've created the storage profiles, which should be done in a second, we can see them all here. Now I can go apply them to a VM just like I would on premise. So to do that, I can switch to the VM settings view. And here I can see that right now the only policy that's applied is the default vSAN storage policy. So to get my new policies applied, just like I would on a regular deployment, I can edit the settings. And that'll bring up a wizard where for each disk I can go through and associate the relevant policy. So here for the first disk, which is containing our OS, I'm going to assign the policy that I created for the general OS app. The second disk is for our data files. I'm going to use the data file policy. And the third is for our logs. Once I do this in the background, vSAN's actually going to look at those objects and understand whether or not it needs to reconfigure and rebuild them. So if the object was RAID 1 and we switched it to RAID 5, vSAN's going to take that configuration and in the background kick off a task to make it compliant to the policy. Once that's done, we'll see the VM storage policies update. And the compliant check basically tells us that now all of the objects are compliant to the policies that we've created. And if you're like me and like clicking refresh, you can click on check compliance as often as you like and see what the results are. So as part of patch upgrade, I talked a little bit about how we take advantage of this infinite or dynamic pool of capacity that AWS has. Another area where we take advantage of that in VMC on AWS is how we deal with failure remediation. So on-premise today with vSAN, if a device fails or a host fails, vSAN tolerates it, right? We take the data that was on those hosts and we redistribute it across the remaining hosts in the cluster. That's just how vSAN works. On-premise, at that point, it requires human intervention. So you need somebody to go replace the failed device or replace the failed host. In the cloud, we don't need that anymore. So the service is constantly monitoring the health of the nodes in the vSAN cluster. It can detect a failed host on the order of 30 seconds to a minute. Once it detects a failure, it automatically kicks off a process to add a new host to the cluster to replace it. That process takes about 10 minutes end to end. So from the time of a failure, about 11 minutes later, you'll get a new host that's joined your vSAN cluster that you can see in VC that's brought resources back up to what you had purchased. At that point, the service is monitoring the health of the host both through vSphere data and also through AWS APIs. So if the service can determine that the failure was permanent, it can terminate the host. If not, it can wait for the CLOM timeout, much like we would on premise, to see if the host is going to come back, and then we can avoid rebuilding all of the data. If the host doesn't come back, we'll kick off rebuild, it'll go to the new node that we added, and then we'll terminate the old instance. And before we terminate an instance and give it back to AWS, there's a check in the service to ensure that it doesn't hold the last unique copy of any piece of data. From a customer standpoint, this all happens transparently. Failures are our problem to worry about, not your problem, and we remediate them for you. And the same underlying infrastructure that we're using for failure remediation, we can also use to dynamically grow and shrink your cluster. So part of the value that we see in the public cloud is that as your workloads change, you can provision more nodes, and as your workloads get smaller, you can remove nodes. And that elasticity is very valuable. And so here, once you've provisioned an SCDC, you have the ability to add nodes up to the maximum limit or subtract nodes down to the minimum limit as you see fit. And from a customer standpoint, you don't have to worry about any of the configuration. All you have to worry about is how many nodes you want to add or remove. We have a quick demo to show you what it actually looks like. So for those who haven't seen it, this is the default landing page. So when you come to the VMware portal and you've provisioned an SDDC, this is what you're going to see. This is a 4-node cluster. And you can see it's telling us we've used 2% of our storage, and we have about 83 terabytes of available capacity.
So that sounds like a perfect time to add another cluster to the host.
Exactly. So assuming I can click on the demo, I can go to the Actions tab, and I can select Add Host. And it'll bring up this wizard. And here, everything's been filled in. The only option for me is how many hosts do I want to add. In this case, we're going to add 1. Underneath the covers, that kicks off an asynchronous task. Like I said, it takes about 10 minutes. So in the video, we fast forwarded so you don't have to sit here and wait. Once it's done, we're going to get a notification from the service that tells us, hey, your host has been added. Now, at this point, we can use the connection info from the portal, which basically tells us how to log into VC. And we can see that now we have 101 terabytes of storage. And if we go to the data store view, we can look at the customer workload data store and see that the capacity has been added. So I'd like to turn it over to Ben now. We'll talk a little bit about some of the things that we're working on and some of the directions that we think we can add some more value in the future.
Yeah, definitely. Thanks a lot, Matt. So before I start talking about some of the future directions, we will have time at the end for any Q&A. We're hoping to leave quite a bit of time. We know we have a lot of people here, and I'm sure, Matt, you've been inundated with questions on this, the same as I have. So we're sure there's questions out there. When it is time for Q&A, we have two microphones just here. So please, form orderly lines behind them, ask questions, and we'll try and cover as many as we can. So thanks a lot, Matt, for sharing that. I think what Matt showed was a lot of the value that customers are able to get from VMware Cloud and AWS. That ability to very quickly expand and also contract your cluster in response to demands, how we take care of handling the failure tolerance and so on your behalf, automatically remediating host failures and so on. So really, what you're getting is all of the benefits of the SDDC stack that you're familiar with, but you're also being able to leave behind a lot of management that previously you have to be concerned with. You don't have to rack and stack hosts anymore. We've gone from an environment where customers are putting together separate storage, compute, and networking systems together. That's evolved to HCI. As you guys move to hyper-converged infrastructure, as you're using vSAN and vSphere, you see that there's a huge improvement in ease of use, being able to get stood up very quickly in simplicity. And we're just continuing that evolution here. So now we're just removing the need for even considering the hardware, but you're still getting all the value from that software that you come to expect. The storage policy-based management, the NSX networking, and the vSphere on the hypervisor. So just a little recap there before we start looking forward. So one question that I often hear is, well, this sounds really great, but is that it? Are you guys looking at doing anything more? Well, absolutely, we're looking forward. And let me talk a little bit on some of the specific storage areas that we're looking at further development on. So the first one is in terms of effective capacity. If you look at the raw capacity devices that you have, you'll take off some metadata overhead. You have some slack space that you would take off a recommendation, and then depending on what erasure coding you're using, you would take off some overhead for that as well. And that gives you different capacity that you would present specifically to your virtual machine. And so initially, we've really optimized for resiliency and for performance in this environment. As we go forward, we're really looking to provide some lower cost options as well, and really enable increased effective capacity. So this is enabling us to move not just from the focus on resiliency and performance that we have right now, but making this more attractive to a wider array of workloads as we increase effective capacity by enabling compression and dedupe in this environment. So what you do have within this environment is still the ability to have control over RAID 1 and RAID 5 today. So you do have some levers to control there. This is enabling you to have additional levers to really turn that on the cluster level. So another really interesting capability is what our story is looking across or outside the single AZ. So what we're doing initially, we're deploying the SDDC environment into, I think Matt showed a diagram earlier where we provision a VPC on your behalf. We provision an AWS account on your behalf, and within that we provision, there's a VPC configured. And within that VPC, we configure a subnet, which is where we're basically defining kind of the underlay network, and we're adding the configuring the host and so on into that availability zone onto that subnet within the VPC. So that's where we are today, and we're tolerant to host failures. All the greatness that you get with vSAN today for tolerating those. But there's a huge amount of interest that we've been hearing from customers on wanting to be able to be tolerant not just to host failures, but to failures of entire availability zones. So this is definitely an area that we're really working on very fervently with our colleagues on the networking team as well. But the goal here is that we want to provide you the capability of being tolerant to an entire AZ failure within AWS. And the key thing here, the key differentiation here, is being able to do that without having to re-architect your applications. So typically, when you are looking to, if you were looking to adopt, say, a public cloud, like AWS, for example, lift and shift is not necessarily like a great method to do that. Particularly if you're looking to be tolerant to AZ failures, you typically would take your traditional applications and you look at how you can re-architect them to be resilient at the application level. Well, we're looking at that problem and we're looking at adding in resiliency at the infrastructure level for you so that you can get the capabilities that you would be familiar with vCenter stretch clustering and be able to leverage those across this environment. So the capabilities at the data layer, supporting nested RAID levels, so we can do RAID 1 mirroring across sites and RAID 1 or RAID 5, RAID 6 within a single AZ. So you have full control over that capability. You get the benefits of HA, vSphere HA, to be able to restart your workloads in the event of the hosts on one site going down, being able to be restarted on the other site, or even being able to do proactive migration so you can move from one location to another. So they're all areas that we're working on. There's a lot of challenges. We're certainly working on that on the storage side. On the networking side, challenges ensuring we have a consistent layer 2 IP space that we can move workloads across, and various other things that we're working on. But this is definitely an area that we see a lot of interest from customers, and so we're working hard on this right now. So another area that customers often look at for VMware Cloud on AWS is what use cases can I use this for? What is it suitable for? Well, there's certainly a lot of use cases that are going to be applicable right now. Certainly test dev workloads, bringing in, if you're looking to have regional capacity, being able to open up into like the regions that we have available for this, rather than having to spin up new data centers. So there's a bunch of things that you can do with it today, but one of the really key use cases that people have been really grabbing me and trying to talk to me about is around disaster recovery to VMware Cloud on AWS. So I actually have another session immediately after this one where I'm doing a tech preview of this. So if you're interested in that subject, I'll go into it in a lot more detail in that session. But suffice to say, what we're looking at doing is bringing our established disaster recovery capabilities and looking at how we can bring that to bear on VMware Cloud on AWS. So from a DR perspective, the capabilities around orchestration with Site Recovery Manager, the ability to replicate data with vSphere replication and so on, looking at how we can enable those capabilities as a service with VMC on AWS, and really as a service, ensuring we're simplifying it for your consumption as well. So making it something that's easy to just be able to activate and turn on in your SDDC, and then begin protecting workloads to VMware Cloud on AWS. So as I mentioned, this will be delivered as a service, building on our established DR capabilities, runbooks, automation, and so on. And really the key benefit here is that so many customers that I speak to, they really get the need for DR. They really want to have DR, but they really don't want to spend the money having a second data center and managing that and all the operations and facilities that come with opening up a secondary data center. And they're like, hey, this is DR is often one of those projects that's maybe like the number 2 or number 3 project, but there's so much capital expense in opening up additional data centers, buying additional storage arrays, and so on. They often kind of falls down the priority list. But with this, looking at options around pay-as-you-go and longer-term contracts as well, this gives you the flexibility to very quickly spin up that additional capacity. Now, as Matt was showing, he could very easily, expand, the cluster within a few minutes. We can very quickly set up an SDDC. There's just a button to kick off the process. You provide a few details. You can link it to your AWS account and set up some VPNs. And within a very quick period of time, you have an entire secondary infrastructure stood up and running. So let me talk a little bit now about not just what VMware are doing by ourselves, but what we're doing with our partner ecosystem. Because we told you lots of great stuff that we're doing with vSAN and what we're looking to do with SRM and VR. But we're really cognizant as well that it's not just about the technologies that VMware deliver. It's the technologies that you're used to using today, what you work with, the other partners and vendors that you really have those relationships with. And what we're looking to do is enabling you to leverage that ecosystem in this environment as well. So this is just a few key areas that we're looking at within the storage and availability business unit. The first one is around the VM-based backup solutions. So we've been working very closely with some of our partners. There's a few mentioned earlier today. Obviously, Dell EMC, a very close partner of ours. Veeam as well. We've been working on this as well as others. looking to bring their solutions into this environment. So here we're looking to enable VADP-based solutions to be able to, back up virtual machines that are running within VMware Cloud on AWS. A lot of these technologies are then taking those copies of the data and being able to persist it into the AWS storage tiers. So things like S3, potentially tiered off to Glacier and so on. So what we're doing here, we're really taking this rich ecosystem and we're bringing it along with us and enabling that ecosystem to also take advantage of the additional AWS services that are there to provide different storage economics for backups and so on. And then the second use case here that I'll talk about is also enabling third-party disaster recovery solutions. So obviously, once it's available, and bearing in mind the disclaimer that I said earlier that we're working on it, but if and when it becomes available, we'd be very happy to sell you our DR service. But we also know that there's a lot of other solutions out there in the marketplace that a lot of customers are choosing for their DR capabilities. And so we're really looking to enable those as well. So whether it's those that are based off of, say, backup technologies and using that for DR, backing up to the cloud and recovering into the SDDC, or those that are using more advanced technologies like vSphere APIs for IO filtering. We're also looking at how we can work with our partners to enable those technologies within VMware Cloud on AWS as well. And then the third one, as well as availability, let's talk about storage. We certainly see vSAN as a primary storage capability for your virtual machines. That's kind of the bread and butter. We're really focused on that. That's going to be the primary VM storage location for you. However, there are use cases where customers, may wish to use other external storage systems. And while, we see vSAN being a great fit for a wide variety of use cases, right the way through from business critical applications all the way down to test dev, there may be other use cases like file services, file storage, and so on that you wish to use other vendors for. And so what we're looking to enable is also working with our partner ecosystem to look how we can enable things like NFS or potentially iSCSI or another IP-based storage with VMware Cloud on AWS. Working together to see what makes sense for our customers and what we can enable. So we're definitely working hard on that as well. And really, this goes to the overall message that I'm going to refer back to as well, that what we're delivering with VMware Cloud on AWS is really enabling you to take that SDDC, the stack that you're familiar with, the operations that you're familiar with, be able to take away the operations that you don't really need to worry about, but bring the consumption operations, how you manage your virtual machines, how you configure and deploy, your integrations with VRA, VROps, and so on, bringing all of that together, as well as third parties like backup solutions, DR solutions, and so on, bringing that together to give you an experience or a solution that really meets your needs, that gives you all the data services and capabilities that you require, but still giving you the benefits of the elasticity and the agility of the cloud within that environment. So this is a quick rundown on the ecosystem, and ecosystem is a very important part of this project as well. And then the next thing that I'm going to talk about, Matt gave a really great overview of, what the current configuration looks like. We have a fixed host configuration right now, and the cluster sizes will be, anything between 4 to 16 hosts within the cluster, and a single cluster per SDDC. So as you can imagine, this is what we're launching with. This is kind of the initial release that we have. But we're not looking to stop there. We're looking to expand further. And as our customers grow, we want to grow along with them as well. So what we're working on is not just, in a couple of different axes here, not just going from up to 16 hosts per cluster, but looking beyond that, enabling customers to scale up as they need. And then also enabling them to scale out the number of clusters as well. So not just having a single cluster for all your workloads, but potentially being able to, have dedicated clusters for certain workloads. vSAN's a great solution for mixed workloads, but for some, you may have licensing considerations where you'd rather have a dedicated cluster for certain workloads. So that's what we're looking to accommodate here as well, and what we're working on. But really, the goal here is that we want to bring that capability to you, where you can start off small, you can grow as needed, you can contract where you need to, and giving you the flexibility to be able to manage that. but not have to worry about the hardware procurement and all of that. You just say, hey, this is what I need. VMware, go build that for me, and click a button, and we take care of that automatically for you. So hopefully that's given you a little bit of a taste for some of the things that we're looking to do and that we're working on that I can share with you right now. For those of you who are under NDA, please feel free to talk to us in the under NDA sessions. We can talk a little bit more about other things that we're working on. But we're going to take the opportunity I'll give you guys the opportunity now to ask us any questions that you may have. And I'll also point you to, please feel free to fill out the survey as well. We will be checking that, and that will really help the people in Barcelona when we repeat the session. So good feedback there would be appreciated. So we'll take any questions. If you have questions, please come to the microphones at the front here. Thank you.
Go ahead. Sure. Hi. So you mentioned that you do plan to offer support for the external storage from VMC. Any specifics about the timeline?
No, sorry. Yeah, revenue, like my legal team wouldn't let me have put that slide up if I had timelines on it, so I can't say timelines. So the question was, it's something that we're working on. We see it as a need. We've had customers asking for that capability. So we're looking at what it would take to do that. We're working with partners on that, but we can't commit to anything. There's especially as we're operating in an environment where I think Matt made a really great point earlier, actually, that what we're used to dealing with on premises is a certain type of hardware configuration. When you move to the cloud, things are a little bit different. How the networking works and all those things are all challenges that we need to look to overcome and work on. So we are cognizant of the need for that. We're hearing it from customers. We are working on it, but we can't commit to being able to actually do it, or when it would be done by. So I'm sorry I can't provide more detail publicly. Thank you. There's a question here.
Yeah, so a follow-on to that question is, can you expand on what you mean by direct connect external storage? So are you thinking like a filer sitting in an Equinix facility?
So let me tell you a couple of examples that we're working on. But I'm going to refer back to the disclaimer that this is not a commitment. But the kind of use cases that we're thinking of here, there's a range of them. One would be, for example, exactly that, a filer sitting in an Equinix, direct connected in, being able to, provide a couple of things. One, maybe initially in-guest access to that filer. The second would be looking at, maybe exposing that over, say, NFS as a data store. There's like a couple of different use cases there. The networking challenges are a bit different for both of them. But that kind of, colo Equinix type solution would be one example. Another one would be some of our partner ecosystem has software-based storage solutions that they deploy onto EC2, for example. So maybe customers deploying like those vendor storage solutions onto EC2 backed by UBS. Those kind of solutions, being able to deploy those, hook those in, connect them in via the network interface that we'll have between the customer's VPC and the VPC where the VMC is located. And so definitely, in-guest, that's probably going to be simpler to validate initially. It's just in-guest. There's not much that we get in the way of. But if you're looking at, data store attach, exposure as a data store, for example, that gets a little bit more complicated. And there's a lot more challenges that we'd need to address with that. But we're definitely thinking of those use cases. But as we're thinking of it, we talk with customers and partners about it. There still needs to be an overall prioritization. And I can't commit to any dates or times right now, unfortunately.
Thank you.
Thanks. So we'll kind of alternate. So I'll go to this side here.
I guess two parts. One, I'm aware of some storage vendors that are putting their arrays in AWS. Mm-hmm. So I'm wondering if you guys will play nice with them. And part two was more about the hardware you're putting in AWS in the cloud. Mm-hmm. What clock speeds are those CPUs, and will there be an ability to select clock speeds? Because if I've got a workload, I'm looking for faster clock speeds than a general 32 cores.
Okay, I can go that with Matt. Do you want to take
Sure.
that one?
So from a hardware standpoint, it's not the hardware that we're putting into Amazon. It's the hardware that Amazon's building. So the bare metal instance type is something that's available beyond what we're using it for VMC on AWS. As a customer, eventually you will be able to provision your own bare metal instances. So we don't actually control that level. That's Amazon's, what they're going to differentiate on. So today, I believe that the answer is no, and that'll be something to follow up with on Amazon. For the first question, in terms of storage vendors that we see moving their software to run on top of public cloud infrastructure, I think Ben touched upon this. We see a bunch of vendors who are doing this, and we think that's going to provide value for a bunch of different use cases. Things like in-guest access, where you want file access for NFS or SMB or for whatever you're using, and eventually for other things as well. Storage vendors or backup vendors who want to expose a data store for instant recovery and things like that. So those are all in the list of things that we're considering and really trying to figure out how we can provide value for customers.
For me, it's the easy button of array-based replication.
Okay.
Sure. And data movement from in and out.
Thank you.
Thank you.
I think the only comment I'll add to that, the question was, are we going to play nice? The answer is we want to. It's for us, we want to bring the ecosystem along with us. That's kind of one of the guiding principles here. So we'll go over to her.
Hi, where does the AWS platform stand as being a way to back up classified information or to extend storage for the DoD?
Yeah, so we are working on, so not today. I think that's kind of the first answer. So we are working on a variety of different compliance requirements like FedRAMP and things like that. We're not there right now. We have a roadmap to get there. I can't share that roadmap publicly, unfortunately, but it's definitely an area that we're working on. I think we mentioned earlier the current configuration. We are encrypting data at rest, but that's using keys that AWS manage and control. And this doesn't necessarily talk specifically to your question, but as a general principle, a lot of the compliance regimens they require more control over the key management than that kind of solution would give you. So as we're working on improvements to key management and encryption and some of the networking capabilities that we'll be providing as well, that helps us check a few of the boxes on the compliance roadmap. And as we look to expand out to other AWS regions, including things like potentially GovCloud and things like that in the future, we'll be checking more of those boxes.
But you're optimistic about the roadmap, such as 2 to 3 years.
I'm not responsible for the roadmap, so I'm neither optimistic nor pessimistic. And unfortunately, I can't really share much more than that.
Something we've definitely heard from customers as being important. So I think that's about all we can say.
Yeah, thank you.
Thanks.
Yeah, just a quick thing. If you guys ask me roadmap questions, I can give you general guidance, but I can't say dates or times or anything like that. I'm sorry. It's I would get really told off if I did. So. All right, go ahead.
Yeah. Is there a conversion step involved as VM is moved from on-prem to the VMware cloud on AWS? Earlier I was thinking there is none, but it seems like the bootable device is still in EBS.
Sorry, can you repeat the question again?
So VMDKs on NFS on-prem,
yes.
Can they be directly moved to VMware on cloud, or is there a conversion step involved there?
So what we'll support at the initial availability, or what we support at the initial availability, is cold migration of your workloads from on-prem to the cloud. Live migration isn't quite there yet. That's another area that we're working on. But the technology that it uses, you'd be familiar with. It's using storage vMotion basically doing a storage migration for that portion of the data.
Cross-cluster storage vMotion.
Cross-cluster storage migration. Now it is a cold migration though, so that would be the technology that we'd use initially today. What we're looking at on the roadmap, as I mentioned earlier, was more the disaster recovery use case, where there's some different behavior with that, where the replication is again at the VMDK level, but that is something that you can set a RPO on, and it can be replicating over a long period of time. And then when you want to do the migration, we will do a final delta sync, just the small piece of data that's changed since the last point, and then do the switch over of the VM. So it's a slightly different behavior from a cold migration, which is you kick it off and you wait for it to be done, however long it takes, versus kind of a replication incremental kind of approach that we're also working on.
So, just to understand, there are no change in the number of files, like number of bootable disks or something in cloud versus local?
So you're replicating to like a vSAN cluster, and so I look at the vSAN guidance in terms of that, but typically no. You'd be able to. There's pretty good sized clusters. The number of storage objects and so on that we support within vSAN is pretty high, so there shouldn't be an issue. But I think probably what we test to is typically around about 100 VMs per host, typically. So if you're on that kind of order of scale, I wouldn't have any issues. Thank you. So over on this side.
Hi. One of the central tenets with AWS architecture is you should always span AZs, right? And that's teach your first day in the AWS class. So my first question is, as a customer, should I be concerned about running production applications in VMware on AWS until that feature is available? And follow-up question is, when the stretch clustering is available, will I be able to stretch a 4-node cluster across 2 sites, or will I have to have 2 separate 4-node clusters?
Sure. So I think the answer to your first question is always what level of risk that you're willing to tolerate, and also when you say production, exactly what kind of applications you're talking about when you say production, because maybe production application, like part of the application, like the web tier or something like that, it may not be an issue, but your heavyweight databases where you want to be truly resilient to AZ failure, there's critical data there, then probably not initially. You'd look at what the AZ story is. But let's just be clear, we're resilient against host failure, so we have the host failure capabilities. AZs can fail. It does happen. That's why the guidance is to architect against that. Depending on your level of risk, though, you may choose that, hey, I'm going to still put it there, and I'm going to rely on backup capabilities to be able to back up those workloads. And hey, if there is an AZ failure, I'll spin up another SDDC and I'll recover my VMs from backup. It depends on what level of risk you're willing to take, what kind of recovery times you're looking for, the RPOs. So it's definitely something to consider. I wouldn't say it's a blanket yes or no. There's a few different aspects to consider on that question. And then the second part of the question was, would you just allow like a 4-node cluster to be split and spread? So obviously I can't talk too much to the specifics of what we're working on, but likely not due to the architecture of how we have vSAN. We'd likely want more hosts on each AZ, so this would be a bigger configuration.
I think in general, when you start looking at stretch cluster, we want to be resilient to failures within one side without having to move data back and forth between availability zones. So conceivably, that would have implications for what you want for a minimum cluster size on any given side.
Yeah, and then probably what it will scale up to, I can't really comment on that, but if you look at what we scale up to today, which is like 15 and 15 and 1 witness, that would, that kind of ballpark would be what you'd be looking at going up to. All right, thank you.
Is there any knowns around the underlying hardware refresh of the equipment that the nodes would be hosted on? Is that going to be tied to like contract cycles, or is that still not known?
So it's not directly tied to contract cycles in terms of the lifetimes of the host. I don't know, Matt, if you want to talk to this,
so
or I can.
Are you looking about like hardware refresh for new hardware cycles, or in terms of just endurance of devices and hardware being recycled of the existing line?
Yeah, so I mean, if you're renting nodes, vSAN nodes in the AWS cloud, somebody asked the questions about CPU speeds. Obviously, those are going to increase over time. Memory speeds, CPU speeds.
Yeah.
In an in-house data center, you'd have
a hardware refresh.
You'd have a hardware refresh. So what does that look like in the AWS cloud?
I think if you look at AWS in general, you see this with their existing instances, right? So they have, i3, M4, R4, and they're constantly rolling through those, and as hardware revs, they're rolling out a new rev. And I can't go into any specifics, but I would imagine that for the bare metal instance type, you're going to see the same thing. I think the difference or the caveat that we want to call out is today Amazon has a ton of different configurations because they're virtual machines, so it's really easy to take hardware and carve it up into pieces. For the bare metal instance types, I wouldn't expect necessarily to see thousands of different configurations, but instead a small number that are going to rev and keep pace with hardware as it evolves.
Yeah. I think the direction that I think you'll see is taking is that as we work with AWS, if new capabilities do become available, we'll look at how we can leverage those. But we're dependent, both on the AWS side and also on our side to deliver on that. Right, over on the right.
So very interesting stuff. We actually have an on-prem vSAN environment that we're looking to extend out to the cloud. The one question I had is about the licensing model. So I'm guessing that's going to get incorporated in the cost when we build this. Is there a way, we're a VMware service provider, so is that licensing model also going to extend to that? Or are there plans for that?
Okay, that's probably a question I'm not able to answer. Okay. I'd have to refer you to one of our product marketing team. So please feel free to come up afterwards, and I can get you details and put you in touch with the right person for that. Thank you.
You had mentioned that there's integration with the AWS services. Maybe haven't actually explained what they are, how they integrate, or what's available at launch, or because I see this as a great thing for an admin. I'm like, it's a lot less work for me, but I have to be able to sell this to management.
Sure.
I have to show why this is different, other than it's fancy and new.
Yeah, other than it's on AWS, and okay. Let me touch on that a little bit. So this session was primarily around kind of the deep dive on the storage aspects, so that's why we didn't go into it. There's a few other sessions. But essentially, one of the key, there's two aspects to it. One is we're just really close. We're actually on AWS hardware, so latency networking is going to be super fast. That's kind of a given. The second thing is that we've been worked with AWS, and they've developed a new type of interface between the VP. When we spin this up, we create an AWS account for you as a customer. For the VMC side, it's one that we manage, and within that we configure a VPC where we deploy our pieces. You link that with your own VPCs with your customer account with AWS. With those accounts, then what you're also able to do is configure an elastic network interface between the two, and this is a very high performant connectivity between the two that will allow you from the VMC side of things for your workloads to be able to reach into your own VPC. So all the the EC2 instances that you deploy within the private VPC instances, you can you have routing to them and they can communicate. If you have like an S3 endpoint that gets deployed, you can have the endpoints deployed within your VPC. We can communicate with those over this as well. And so there's a couple of the examples of because of this linkage and the connectivity between the VMware side and the AWS side, that you do have that access to those kind of resources that you wouldn't necessarily have from the outside.
I think in the short term, it's really sort of what Ben mentioned, which is we're taking your workloads and we're placing them in the same data centers where AWS services are running. So from a latency and bandwidth perspective, you have capabilities that you don't necessarily have on-prem, or you'd have to pay a lot for with Direct Connect to get sort of the equivalent. I think again we're limited about what we can talk about in the future and future integrations, but one of the things that really excites us about AWS is all of the native services that we have, and we think there's a lot of integration that we can do to add more value. Unfortunately, we're limited in what we can talk about.
If you build an AWS load balancer, would you be able to get to that?
You'd probably have to talk to one of the other teams on that. We're really focused on the storage side of things. So as when you get a little bit outside of storage, we probably couldn't give you the answers that you'd be looking for. But there's plenty of other sessions. And if you want to talk to me afterwards, I could refer you to another PM if you can't get answered. All right, we have a couple more people here.
So for VADP backup providers, is that backup all stored on vSAN as well? Is there a way to separate it out?
No. So what we enable for the backup providers is, due to a few changes within VMC, there's a new VDDK that we provide to the vendors. But what they're able to do is leverage the same vSphere API for data protection connectivity to basically grab that image of the VM. And so the proxies can come in and grab that from the vSAN data store.
So now, unfortunately, I think we're just being told we're out of time. Happy to talk with you after this. I can give you a more detailed walkthrough. For folks who stayed, I think someone dropped off a bunch of VMC on AWS t-shirts in the corner. So if anyone's looking for swag, feel free to help yourself. And thank you very much for coming.
Yeah, thank you.